Desktop computers are sophisticated machines that transform electrical signals into the digital experiences we interact with daily. At their core, these devices process information through a carefully orchestrated system of electronic components, each playing a specific role in converting your commands into tangible results. The central processing unit, commonly known as the CPU, serves as the brain of the computer. This silicon chip contains billions of microscopic transistors that switch on and off millions of times per second, executing instructions in a language of ones and zeros. When you click a mouse or press a key, the CPU receives these inputs as electrical signals, processes them according to programmed instructions, and determines what actions to take next. Working in tandem with the processor is random access memory, or RAM. This temporary storage system holds data that the CPU needs immediate access to, functioning like a workspace where active tasks reside. Unlike permanent storage, RAM is volatile, meaning it loses all information when power is cut. The speed at which RAM can deliver data to the processor directly impacts how smoothly applications run and how many programs can operate simultaneously. The motherboard acts as the central nervous system, providing the physical foundation that connects all components. This large circuit board contains intricate pathways called buses that allow data to flow between the processor, memory, storage devices, and expansion cards. The chipset embedded in the motherboard manages this communication, directing traffic and ensuring each component receives the information it needs at precisely the right moment. Permanent storage devices preserve your data even when the computer is powered off. Traditional hard disk drives use spinning magnetic platters and moving read-write heads to store information, while solid-state drives employ flash memory chips with no moving parts. When you save a document or install a program, the storage device writes this information in a way that can be retrieved later, translating the abstract concept of files into physical patterns of magnetic fields or electrical charges. The graphics processing unit handles the complex mathematical calculations required to render images on your display. While the CPU excels at sequential processing, the GPU contains thousands of smaller cores designed for parallel processing, making it exceptionally efficient at manipulating the millions of pixels that comprise modern high-resolution displays. Every window, icon, and animation you see results from the GPU's continuous calculations. Power flows into the system through the power supply unit, which converts alternating current from your wall outlet into the direct current that computer components require. This unit distributes different voltages to various components, with the motherboard receiving 3.3 volts, 5 volts, and 12 volts through separate rails. Stable, clean power delivery is essential for reliable operation. Heat generation is an inevitable consequence of electrical resistance and transistor switching. Cooling systems remove this thermal energy to prevent components from overheating and throttling performance or suffering damage. Heat sinks made of aluminum or copper draw warmth away from processors through conduction, while fans create airflow that carries this heat out of the case through convection. Input devices translate your physical actions into digital signals the computer can understand. Keyboards convert key presses into scan codes, mice track movement through optical sensors or laser technology, and microphones transform sound waves into electrical signals. Each input device communicates with the motherboard through standardized interfaces, sending streams of data that represent your intentions. Output devices perform the reverse transformation, converting digital information back into forms humans can perceive. Monitors receive video signals and illuminate pixels to create images, speakers vibrate to produce sound waves from audio data, and printers deposit ink or toner onto paper based on digital instructions. These devices serve as the bridge between the computer's internal digital world and our analog reality. The operating system software orchestrates all these hardware components, managing resources and providing a consistent interface for applications. This complex program handles memory allocation, schedules processor time among competing tasks, manages file systems, and translates high-level commands into the low-level instructions that hardware understands. Without this software layer, the hardware would remain an inert collection of components. When you perform a simple action, like opening a document, an intricate chain of events unfolds. The input device sends a signal to the CPU, which consults the operating system to locate the file on storage. The storage device reads the data and transfers it to RAM, where the CPU can access it rapidly. The appropriate application loads, the GPU renders the document's visual representation, and the display shows you the result. All of this occurs in fractions of a second. Desktop computers represent a remarkable achievement in engineering, combining precision manufacturing, sophisticated software, and fundamental physics principles. Each component contributes its specialized capabilities to the collective whole, transforming electricity and silicon into a versatile tool capable of calculation, communication, creativity, and countless other tasks that have become integral to modern life.